I got 1/2. That's what I got. What? What about you? Yeah. Johnson, you still like partially vegan?
All right. Here's what I've got. Oh, I lost it. Now, here on this one, either one of these answers would be acceptable right here. You could leave it as a negative exponent, or you could send it back down to the bottom. It just would depend on what you're looking at.
I multiplied the 3, like the inside of the chain rule. I multiplied that by the inside of the parentheses.
Oh, so you got like 9x minus 12.
I ended up getting 9 over 2x minus 6.
Yeah, I can't do that.
Yeah. I mean, I had to write it down.
Yeah.
Yeah.
All right, so what rule are you using here to take these derivatives? This is chain rule, right? So there is a function inside of a function that you are taking the derivative of. So if we try to integrate something that is a chain rule problem, so far we don't know how to do it, but I'm about to teach you. So let's move on here. So right here, this is our U substitution rule here. So if I have, this is really written in like 2 separate ways. The bottom way is the way that I like better. So these 2 things right here are equivalent to each other. They're just using different notation right here. So if I have a function that is f of g of x, and it is multiplied by g prime, then when I integrate this, I will get capital F of g of x plus c. Yeah, it's extra fun that if you use the u there.
Why didn't we learn this before we did our shirt?
You're right. That
I
would
would say a lot of good things.
Yeah. So in this second version, which is going to be more of what we're going to use because we're going to use that letter U quite a bit, here instead of using g of x, to simplify that a little bit, we just put a u, and then du is the derivative of u there. And when we integrate lowercase f of u, we get capital F of u plus c. Now, this is really just how we integrate right here, because when we integrate this with respect to u, then the du is just telling us the variable that we're integrating with respect to, and it goes away. Whenever we integrate the function so that it becomes capital F. We put the plus c on the end for our constant. So what we're going to do here is we're going to take an expression that's more complicated, and we're going to rewrite it using substitution to make it an easier integral that we do know how to do, and then we'll integrate it and replace that back. So this is called integration by substitution, or a lot of times I just call it U substitution because we typically use the letter U, although you could use a different letter if you prefer. If the F of U offends you in some way, you can use a different letter if you would like. So in this function right here, what we need to think about is what our inside part would be. Sometimes it is pretty easy to see. In general, if you have an expression being raised to a power, the inside part is usually whatever is on the inside of that. Some of them are a little harder to see. Today they'll be mostly pretty easy to see. These are going to be our beginner problems that we'll be doing today for these. So what I'm going to do is I'm going to say U equals x squared plus 1. Okay, then I need to take the derivative of this. When I take the derivative of this, I will get du dx equals derivative of x squared plus 1 is just 2x. But I want this, like what I'm trying to do is I'm trying to write this integral where everything's in terms of u's and I just have a du. So I don't want du dx, I just want a du. So I'm going to multiply both sides by dx right here, which is going to give us du equals 2x dx. So our goal is to replace everything in that integral with u's instead of x's so that it will be a function that we can actually integrate. So u is equal to x squared plus 1. So right here where I see x squared plus 1, I can replace that with u. And du is equal to 2x dx. So where I see 2x dx, I can replace that with a du. So when I make that replacement there, it will look like this. I will have u squared du. Now, do we know how to integrate u squared du? We should. That should be a very basic one, right? Like, we're just increasing our exponent by 1, which would be u to the third, dividing out front by that 3, so we get 1/3 u to the third. And it's not exactly mathematically correct to say that du gets replaced with a plus c, but it's not a bad thing to think about whenever you were doing this. When you integrate, that du is telling you the variable that you're integrating with respect to, and whenever you do that integration, you got to replace sort of that du with a plus c. But that is not, the u was not the variable we began with. So like if I took the derivative of this, it would not give me this answer right here. So now I just want to take that x squared plus 1 and plug it back in for my u over here. And I'll get 1/3 x squared plus 1 to the third power plus c. And that will be my answer. So the whole idea is that we are taking out a piece and calling it u so that we can rewrite this to make it an easy integral that we actually know how to do. And then we go plug that complicated piece back in at the end once we get our answer. And these are also fairly easy to check yourself on because if I want to check this, just take the derivative of what you've got here. So if you take the derivative, you would do 3 times 1/3, which would just be 1, x squared plus 1 to the second power. you would have to do chain rule and multiply it by what's on the inside, which would be 2x, and the plus c would just go away. So if I were integrating here, I'd have x squared plus 1 squared times 2x. The dx is what you're putting in there when you write it as an integral. So I'll show back up. So you can check to make sure that you got it right. Okay, questions? All right, let's try another one. Let's do a trig one. Okay, so we got the integral of 5 cosine of 5x dx. What do you think the inside should be, the u part should be? This is the 5x right there. This part right here is going to be our u. So u just equals 5x. So if I take the derivative of that, then du dx would just equal 5. But I don't want a du dx. I want just du. So I'm going to multiply both sides by dx to get rid of this. And I get 5 dx. Now, in this case, do I have a 5 dx? Right, I got a 5 cosine. The 5 is there, the dx is there. They're not together. Could I put them together? I could, because this dx is multiplied on the end. So it would be okay to write this way. And you wouldn't necessarily need to write this step, but I'm going to, just because it makes it easier to label things. I could put the 5 over here with my dx, and that would be okay. So I could replace my 5x with a u, and then I can replace the 5 dx with my du. So when I do that, I'm going to switch to u's. I got cosine of u du. What is the integral of cosine? It is sine of u plus c. And then what's the last step I need to do there? Plug the u back in, so I would get sine of 5x plus c. Some of these might be simple enough that eventually you can kind of do them in your head, like without writing down what the u and the du are, possibly. If that's the case, that's okay, but they do also get more complicated than this. So I think it's good to just do these the long way so you're really grounded on the process there. All right, let's look at this one. This one's going to be just a little bit different. We got the integral of x times x squared plus 1 to the second dx. What do you guys think the u probably needs to be for this? X squared plus 1. I would agree. So u equals x squared plus 1. Are you guys okay with me doing this? I'm going to do this. Du equals 2x dx. I'm just skipping that step because when I take the derivative, I get du dx equals 2x. And then I got to multiply both sides by dx. So that happens every single time. So I'm just going to go ahead and put the dx over here.
It's okay with me.
Okay, thank you for permission, Sandra. I was looking for that. All right. So now, here's the issue. I am going to do this. Let's put this x over here with the dx. So I've got x squared plus 1 squared, and then that would be multiplied by x. That'll be multiplied by our x dx. So this part right here is my u. Do I have what I need for the du? No, I've got most of it. There's an x and there's a dx, but what am I missing? 2. And that du has to be there. If it is not, you cannot integrate. So, I really want to just put a 2 right there. And then it can be my du. And I can do that if I do something else to go along with it. No, but you're thinking sort of the right way, because this is not an equal. You're close. Divide the whole thing by 2. Or the easiest way to deal with it is to put a 1/2 out here. Because what you're doing really there, that's just a coefficient. It could go on the outside or it could go on the inside. If you multiply by 1/2 on the outside but multiply by 2 on the inside, those two things cancel each other out, and you have not actually changed the value of the integral at all. So we can, as long as it's just a coefficient that we're missing, we can do this, and now I can replace this with my du. And that will look like this. The 1/2 stays there. The integral of u squared du. And so now we've got it down to a simple integral that we should know how to integrate just with our power rules. So we get u to the third, and then we'll have a 1/3 out here, and we'll put a plus c. I could put those two together and get a 1/6 u to the third plus c. And what's the last thing we need to do? Plug in that u, so we'll get 1/6 x squared plus 1 to the third plus c. Okay, questions? All right, let's look at this one. We got 1 over 3x minus 5 squared dx. This one kind of looks like it also needs some sort of quotient rule or something, and we do not have a quotient rule for integrating. We don't know that, nor will we learn it. So if there is one, I either have never learned it or can't remember it one. We definitely don't have to do it in this class. So I need to think about this in like a u du situation. How could I write this so I don't have fraction anymore? Negative exponent. So I could write this way. 3x minus 5 to the negative 2 dx. And that will simplify this a little bit. What do you guys think the u should be in this case? It should be the 3x minus 5. So u is going to be 3x minus 5. So, Solana, what will we get for the du when we take the derivative of that?
We'll get 3/2.
I think you're integrating. Just take the derivative.
Oh, yeah. Okay.
Just
Just 3.
3? And then we put the dx with it, because we would have du dx equals 3, and then we could multiply. multiply both sides by the dx, but that's going to happen every time. So if you'll skip that step, that's okay. So again, I don't have 3 with my dx. There's nothing over there. Can I put a 3 here? I can, as long as I put a 1/3 on the outside. And so if I do that, I can replace my 3x minus 5 with u, and I can replace my 3dx with du, and I will get 1/3 integral of u to the negative 2 du. And so I would increase my exponent by 1, which will give me u to the negative 1. I'm dividing by that negative 1, which will make this negative. I'm going to go ahead and put that negative with the 1/3. That's the coefficient. Be careful if you have more than one variable and you're doing that. But as long as it's a single variable, those two are going to get multiplied together anyway. And then we'll have a plus c. And so you could just plug this back in, 3x minus 5 to the negative 1 plus c. Certainly, if it's a free response question, just leave it there. They might send that back down to the bottom and make it look like this, 3 times 3x minus 5 plus c. They might even distribute that 3 there. It just depends on how they decide to leave it.
You should always be left with just a u to plug in.
Yes. Yeah. Okay. Questions? All right. We got one more that we're going to look at. So this one tells us to solve the differential equation, and it gives us dy over dx equals x plus 2x squared over the square root of x. It's another way of asking us to integrate. We really don't know how to do complicated differential equations right now. Whenever they're telling us to solve the differential equation, you're going to multiply both sides by dx, and then you're going to integrate both sides. So your y is going to equal the integral of x plus 2x squared over the square root of x dx. Now, what do you guys think what should we do here? Okay, I like that. So make it like x to the negative 1/2. Okay. What should I do then? Okay, Joshua says distribute. Do you guys agree? Okay. So that would be x to the 1/2 plus 2x to the 3/2. Like that. Okay, what next? Whenever you are multiplying x to the negative 1/2 times 2x squared, you're adding those exponents there. So you're doing negative 1/2 plus 2, and that will give you 3/2 for that. Because it's easier whenever it's real numbers, like whenever you're doing x squared times x to the 3rd equals x to the 5th, but you're doing the same thing here. Feels like what we should do. But what would a U be? If I pull out GCF, it's going to kind of get us back. I mean, you might could. But is the U necessary? It is not necessary on this. I gave you this problem. You guys did pretty good with it too. Like you recognized that eventually. But your homework does this to you. It gives you a couple that are not U to U problems. So just because something looks a little complicated, or like is a fraction, does not necessarily mean it needs a U to U. So you're just going to integrate this x to the 3/2. Then you got to divide out front by the 3/2, which just flips that fraction, which will be 2/3. And then you'll have x to the 5/2. Oh gosh, what am I doing here? 5/2. And then we got to do 2 divided by 5/2. Dividing fractions, easy as pie. We get 4/5. And then we put our plus C on the end. So that is your answer. So the homework does that. That puts a couple in there that are not U to U problems. So be on the lookout for them. You don't always have to use U to U. And so your assignment is going to be on page 341, and it's 5 through 23 odd.